Okay, so for our examples for 7-5, we're just going to jump right into it. We're going to solve and graph this one. Now it looks a lot like what we've been doing. These are multi-step inequalities. In this case, really just kind of a two-step thing. And so we're going to solve it just like we have good old-fashioned equations. Our first step, obviously, is going to be to add 3 to both sides. So we do that here, and we get 2y equals, well, -5 plus 3 is -2. And now we're down to the multiply divide stage. And again, if you don't remember your steps, pull those back up. Follow those just like we normally do with equations. Here we're going to go ahead and divide off the 2. And we get y is less than or equal to -2. Now I know there was a negative here, but that is not, I did not multiply or divide by a negative. I multiplied or divided in this case by a 2. Oops, divided by 2, that's actually 1, isn't it? Oh, for Pete's sake. There we go. So we're going to have -1. And when I go ahead and graph that, there we go. When I graph that, we want, again, we know it's going to be head to the left because it's y is less than. And by the way, a little something I should point out to you here is if you leave the variable on the left side, that the inequality kind of points like an arrow the direction you should graph. Now, if it's not, okay, and if it's not on that side, and I'll work that in the next one, you can use what I call the mirror trick. All right, so anyway, y is less than or equal to -1, and so we're going to have 0 and 1 and 2 and -1 and -2. And notice this has that equals part right here. So that means the dot is filled in at -1. And it's going to head to the left as we graph it. Make sure it's filled in all the way so I can tell for sure there. So there you go. Now you've got an example in the next one, and then you'll come back here for a little more work. So again, pause here, go back to class kick, and work a problem, and come back here for the answer. So we've got here, we have -10 is greater than or equal to 1/2 x minus 6. And again, we're going to solve this just like a good old-fashioned equation with that whole, except that we graph at the end thing. So here we can see it's, 6 has been subtracted, so we're going to add 6 to both sides. And this is why it's so important that you had your integer operations down. -10 plus 6 is -4, and that's still greater than or equal to 1/2 x. Now we're multiplied by 1/2 or divided by 2, however you want to look at it. Remember that reciprocal idea? We're going to multiply both sides by 2 over 1 to take care of that. 2 over 1. And as I do that, we are going to get, let's see. Oh, I'm sorry, I kind of lost track there. We're going to get -8 is greater than or equal to x because all this canceled out. Now here's the thing: when you go to graph this, in my opinion, it's a little bit on the tough side. So I use what I call the mirror trick. So I'm going to draw a mirror here, boom, and I'm going to reverse everything. So notice that means I'm also going to reverse the inequality symbol over here. So it's going to become less than or equal to. And then it's still -8 over here. Now when I go to graph that, it's easier to tell what direction to graph it. Because here I get confused. -8 is greater than or equal to x. But x is less than or equal to -8. Makes more sense to me. So I'm going to put -8 here, and I'm going to put -7 and -9 on my number line. And less than or equal to, notice it has that filled in portion. And again, we're heading to the left for less than. There you go. If you have questions, please make sure you raise your hands. Now, the last slide was the example you were supposed to work, so here we're going to continue on to examples from me. Now, this time, as I take a look here, I notice that my variable has a negative attached to it. That means at some point I'm going to have to flip this inequality. This one, I'm going to tell you right now, we're going to be flipping it twice because we kind of have to keep track of the whole graphing thing. But let's get started on it. So let's see here. We're going to first off start off by subtracting 6 to both sides because that's plus 6. -9 minus 6 more is -15. And that's still greater than to -1/3 x. Now I'm going to be using a negative reciprocal in order to get rid of the number in front of my variable, the coefficient in front of my variable. So in other words, I'm going to be multiplying both sides by -3 over 1. Again, this shouldn't be a surprise to you. We've done this before when we're solving equations. Notice, though, the second that I write this negative here, I want to flip this inequality so that I don't forget it, because otherwise I will. So here on this side, I end up with positive 45 is less than x. Now again, I think that's tough to graph. So I'm going to use my mirror trick to flip this over so I get x is greater than 45. And when I go to graph it, so this is actually the answer over here, right? When I go to graph it, I can put 45, 44, 46. Notice how I'm picking like 3 points right around it. Make life easy. And this one we know is open because there's no equals part to it. So it's an open dot, and it's going to be greater than, so it's heading to the right. You have an example coming up after this one. So again, pause here, go back to class kick and work one, and then come back here for the answer. So here, we're going to start out obviously by subtracting 4 from both sides. And I'm going to get negative 2m is less than or equal to 30. And notice I have that negative attached to my variable. That means I'm going to divide by that negative 2. And as soon as I do that, flip this so you don't forget it. So m becomes greater than or equal to negative 15. Now the thing is here, this time I don't have to use the mirror trick because my variable is already on the left side. So I'm going to go ahead and make my number line. Negative 15, negative 14. Be careful when you make your number line there, right? Negative 16. And greater than or equal to, so it's a filled in dot. And this time heading to the right. So there's your answer for our quick check number 2. So continue this video, and we'll do an example with story problem. I know you love those. So here we see using two-step inequalities. Now I think these are kind of fun, and we're going to do a whole bunch of story problems like this in the coming days. An expedition leader estimates that a group of show-shoers? I don't know what that is. I have to look that up. Can carry less than 550 pounds of food and equipment. Notice less than. There's one of those words. The group must carry 336 pounds of equipment as well as 25 pounds of food for each climber. What is the greatest possible number of people in the expedition? Okay, so we know that they cannot carry any more, in fact less than, not even up to 550 pounds. So notice that down here, right? Down here. And we say P is the number of people on the expedition. So we can have 336 times that, or I'm sorry, pounds of equipment, so that's our steady. That doesn't change. We don't multiply that by people. 25 pounds of food per person, right? So 25 times P. All that together has to be less than 550. So again, my 336 for my equipment plus 25 pounds per person, they can carry less than 550. Show-shoers must be who's going to be carrying it for them or something like that. Maybe donkey, I don't know, something like that. But again, what we're looking at is we're going to solve this inequality. I'm going to do that on the next slide. So here we have, we're going to obviously subtract off our 6 from both sides. And we get 25p is less than. So that's 214. Now we're going to divide off our 25. Divide off our 25. It's a 5 over here, I promise. And we get p is less than, let's see, that's a decimal, I think, right? 8.56. Okay, so that's weird, right? You can't have less than 8.56 people. That's gross. I don't know what you're doing to these people. So technically, you would say it's less than 8 people, right? Or I'd say 8 people, right? Or less. So there you go. That's the solution for that one. You've got one coming up here. You're going to write your own. So go ahead and pause your video on the next slide. So you're going to pause here. Alrighty, so the answer to your story problem that you were to have worked in Class Kick. A stereo salesperson earns a salary of $1,900 per month, plus a commission of 4% of sales. The salesperson wants to maintain a monthly income of at least $2,200. How much must the salesperson sell each month? So a couple things to think about. This person wants to make at least. That means this or more, right? You can see the answer here, obviously. But this is what they get paid flat rate. If they sell nothing, that's how much they get paid. Every time they sell something, they get 4%. So if they sell $100, they get $4. They sell 200, they get 8. Kind of the idea there. So we're going to write a let statement. Again, I always like to start these with let statements. Let S equal dollars in sales. Okay. So we know that person is going to have 0.04S Again, that's turning that 4% into a decimal, obviously, plus the $1,900 that they make just for working. They want that to be at least, that means greater than or equal to, 200 or 2,200 rather. So that's what we're going to have to solve. Obviously starts out here, we're going to subtract that 1,900 from both sides. So we get 0.04s is greater than or equal to 300. Now we're going to divide off 0.04. Divide off 0.04. And I don't know, whatever method you want to use, but 300 divided by 0.04 is greater than or equal to 7,500. There we go, $7,500. $7,500 in sales. That's what that means. So in other words, they have to sell $7,500 of the stuff for the store in order to make enough extra money to make that $2,200 so that they make more than just $1,900. That's what that's all about. Alrighty. You have some homework over this. This first day should be the worksheet reteaching 7-5. And it's no story problems on it. I'll give you story problems on tomorrow's homework, but some of them are kind of tough today. You've got some distributive property in there, some other stuff that we've learned that we have to use from multi-step equations. I know you're going to have some fun with it.